All right, remote calculus, welcome to your notes video here for section 1516. Here's the notes that we've done the last 2 days in class. It's going to help you out with homework sets number 2 for chapter 1. I think this is how it begins. So 4 to the negative, you're simplifying each for the first 8 really here. So simplify each. 4 to the negative third, that means it's going to be written down below as 4 to the third. 2 to the negative 8 means it crosses, goes up top and becomes 2 to the 8th. Well, 2 to the 8th is 256. 4 to the third is 64. And that's that cool and even 4. Now, number 1 came, again, pause this whenever you need to. Number 1, came from the book. I would think that's simple enough. You could write this as x to the 4 thirds, fractional exponent. And when we start taking derivatives, you want to write this as x to the negative 4 thirds. So maybe that's what they wanted to see, not 1 over. Start taking derivatives, you're going to run out of antiderivatives. We're going to write it like that first. Then, here we go, something like this. Let's try to do it without a calc. I'm taking the third root of 8. The third root of 8 is 2, because 2 to the third is 8. The third root of 8 is 2. Then I'm raising 2 to the 4th power. 2 to the 4th is 16. All right, again, pause this whenever you need to. Next one here, exponent laws from both Algebra 1 and Algebra 2. I need to do 3 to the third, which is 27, a power to a power. X to the 6th with an x on the outside. That is 27x to the 7th. Oh, man. Let's take a look at this next one. 2 to the 4th is 16. Power to a power, you multiply. That's b to the 4th. b to the 8th is on the outside. b to the 8th times b to the 4th. That's where you add the exponents, b to the 12th. All from Algebra 2, folks. Same thing here with this next example. All right. 6 to the 4th is 36 times 36, 1296. A power to a power, you multiply the powers. Divided by 2y to the 5th. 1296 divided by 2 is 648 y to the 7th. Because you subtract the exponents. And we are rolling, folks. All right, so in this section here, this is the last one. This is an interesting one. You'll see this on a quiz and exam, I would imagine. So you have the same base up top, so add the exponents. X to the 5n minus 1 over x to the n plus 2. Now, we are dividing with the same base, so we are going to subtract the exponents. X to the 5n minus 1 minus n plus 2. I'm subtracting the exponents, which is x to the 4n minus 3. 4n minus 3. That is an interesting one there. All right, so let's take a look at this example here. All right. So the denominator is pretty easy. You're taking the a to the first to a to the first. You're taking the third root of both, so that is a to the third times b to the third. You can break them apart, multiply them together like that. Take them outside of the root. You got the same root that they're, the same cubed root that you're taking the same cubed root of both. That is. You're taking the second root of a, so that's a to the 1/2. We write as a fractional exponent. You're taking the square root of the square root. What we did in Algebra 2 is we multiplied those together. That's b to the first, so that would be b to the 1/4. So if one of these would be a 3, it would be b to the 1/6. You do that times that. That's the 4th root. All right, so what we do now is we get a to be the same, have the same denominator with their fractional exponent. So this is going to be a to the 3 over 6. Down below it's a to the 2 over 6. Here it's b to the 3/12, b to the 4/12. You got a to the 1/6 over b to the 1/12. The bottom for b has a higher exponent by 1/12. The top for a has a higher exponent by 1/6. All right, so on the next page, we're going to do some inverses. All right, so this is really section 1.6 here. Find the inverse of each function. So first off, you want to write this as y equals, so it's going to be x equals 1 plus 2 plus 3y in the square root. X minus 1 is 2 plus 3y. And we're going to square both sides. So now you got x minus 1 is equal to 2 plus 3y. Again, to find an inverse, you switch x and y and solve for y. This is nothing new for you. What you're going to do is you're going to subtract 2 and then divide by 3. So you have y is equal to x minus 1, parentheses squared minus 2 divided by 3. So f inverse of x is equal to x minus 1, all of it squared minus 2 divided by 3. That is the inverse function. All right. Great. And we're rolling here. On this next one, okay, this is interesting. So I'm going to rewrite this as, first off, this is y equals, so I'm going to rewrite it as x equals 4y minus 1 over 2y plus 3. Okay. I'm going to cross multiply here. 4y minus 1 is equal to 2xy plus 3x. Okay. Now I need to get the y's all by them, on the same side. So if I move this over here, that's not positive. Then I just have one negative now. So I'm going to do that. All right. I'm going to factor out the y that they have in common. 4 minus 2x is equal to 3x plus 1. I'm going to divide both sides by 4 minus 2x. And instead of writing y, I'm going to write f inverse of x is equal to 3x plus 1 over 4 minus 2x. Nice. Okay, then what else did we do? We did a few of the following. Oh, no, we got to continue with the inverses. So let's look at this one. Definitely need to continue with the inverses. So f of x is equal to e to the 2x minus 1. Can write that as y equals, so x equals e to the 2y minus 1. How do I free up y, which is in exponents? With e as a base, I attach natural log to both sides, because natural log of e to any power is just that power. Add 1 to both sides, divide by 2. All right, and how I would write my final answer is f inverse of x is natural log x plus 1 divided by 2. And have that down. Again, pause this whenever you need to. I'm going to write the next one here on the board. Another one for finding the inverse, and you should be good on those inverse questions on the second homework set for this chapter. So for this next one, y is a natural log of x plus 3. X is a natural log of y plus 3. How do I get y out of there? Attach e as a base. So that means e to the x is y plus 3. Sorry. Now notice how this began with y, so it may end with y. You don't need f inverse of x there. Y is e to the x minus 3. All right, so let's just do a few more ones that we did in class. So find the exact value. So in these examples, find the exact value of the following. This example. Log base 5 of 125. So we're going to say that equals x. 5 to the x is 125. 5 to what power gives you 125? 3. 3. Let's do this example. Log base 3 of 1 over 27. All right. Then we write like we did in this chapter. In Honors Algebra 2, right, equals x. So 3 to what power gives you 1 over 27? Well, we should know that 3 to the third is 27. So 3 to the negative third is 1 over 27. So x is equal to negative 3. All right, and we're rolling. So next one here. Same thing, find the exact answer. Natural log of 1 over e. Now remember, natural log e to the x is x, but that's not e to the x. So instead, 1 over e is e to the negative first. Just an exponent rule. E to the negative first would be 1 over e. X to the negative first is 1 over x. So that's how you get negative 1. Then here's another one to look at. Log base. Now the book had log base 10, which is kind of silly because that's the implied base. So it should just be log of root 10. But anyway, 10 to what power gives you the square root of 10? Well, the square root of 10 is the 1/2 power. So x would have to be 1/2. All right, so that's how that one works. Pretty nice there. Let me make sure you can see all that. And then honestly, I just got a few more here. Let's do 2 more, and I think that will be great. All right, so I'd expect, I kind of like 2 videos a week or so with this for this semester. So e to the negative 2 natural log 5. If you know e to the natural log x is x, I got to get this as a natural log of something. So I got to put that 2 up there. Remember, that was originally an exponent. So 5 to the negative seconds. E to the natural log of 5 to the negative seconds would be, now I can write this as 5 to the negative second. I could write it as e to the natural log of 120 over 25 first if you want to, and then just get 125 right there. Or I could go this way to get 1 over 25. And I accidentally skipped the one I wanted to do next, but it's no big deal. Last one, I'm going to, again, simplify. We move that, huh? Great. Log base 2 of 6 minus log base 2 of 15 plus log base 2 of 20. In the log world, subtraction means division. Log base 2 of 6 over 15 plus log base 2 of 20. Now, 6 over 15 is 0.4 plus log base 2 of 20. In the log world, if subtraction means division, I can put them together through division. I can put these together through multiplication. This is log base 2 of 8.4 times 20. This has a answer. 2 to what power gives you 8? That power is 3. X equals, well, it equals 3. Don't write x equals 3. It equals 3. All right, there's no x, I know I said x equals on a lot of the other ones, but just write equals 3. Perfect, that's what I wrote in class. All right, folks, this is Yak Math Videos signing out.